This will be part 2 of kinematics. So in part 1 we understood basic terms in kinematics and we understand the 3 types of motion. So we'll start from revising the 3 types and then we'll go into detail of each type of motion. So we'll love this part because in this part I'm going to share you a most important trick that can save you a lot of time in solving kinematic sums. This trick you can use for kinematics as well as you can use in projectile. This will give you oral answers, so stay tuned, just check it. Let's start with the revision of the part 1 video. So we understood that there are 3 types of motion. Broadly classified, there is uniform motion and there is non-uniform motion. Then the non-uniform motion we divided into 2 parts: uniform accelerated motion and non-uniform accelerated motion. Uniform accelerated motion and non-uniform accelerated motion. So before proceeding to any sums, you have to identify which type of motion is it. So let's differentiate the 3 types so that you can clearly understand which type of motion is it when the sum is asked to you. So in uniform motion, since the object is moving uniformly, your acceleration will be 0. So this is a great identification for uniform motion. If your acceleration is 0, then it will be your uniform motion and your velocity is constant. For constant accelerated motion, obviously the acceleration would be constant, and for non-uniform motion the acceleration won't be constant. So you have to look at the acceleration, check whether it is 0, constant or not constant, and you will get your motion, like which type of motion is it. Okay, so now we'll go into detail of each type of motion. So we'll start from uniform motion, then we'll do uniform accelerated motion, and then lastly we'll solve some sums on non-uniform motions. So in uniform motion I'll share the trick which will help you. So let's start with first uniform motion. So uniform motion, as we derived in part 1, there is only one formula in the uniform motion. Here your acceleration is 0, velocity is constant. So there is only one formula, that is your displacement is equal to velocity into time. So this is the only formula which we usually use in this type of motion. So there will be not many sums from this type of motion, but there can be a type of sums which they ask and they can be little tricky also. So we'll solve that types of part. So direct straightforward questions are very easy. They will give you distance, they will give you velocity, they will ask you time, or they will give you time and they will indirectly give you displacement and then they will ask you velocity. So these are the basic types of sums which you can directly do. So we will go on to good sums, which is they will ask you average distance, average velocity. So this type of sums, it can be formed good, like good sums can be formed for this types. So before solving that sums, let's understand what is average. So what is average? Okay, so if I told you I want average of x, if I tell you I want average of x over y, okay, there are 2 terms in average. So your average of x, so you want average of x over y, it is given by integral x dy divided by integral dy. Okay, so just remember this. So average of x over y is given by integral x dy upon integral dy. So for example, let's take average velocity over time. We'll take average velocity over time. So as we understood, here our x is velocity and y will be my time. So I'll take integral velocity is v dt upon integral dt. So if I simplify this, I can write v as dx by dt, and then I multiply by dt. So dt will cancel out. So I am left with integral dx upon integral dt. that is total displacement. Integral dx is integration of dx, so integration of dx will give you total displacement, and integral dt will give you total time. So this way you get your average velocity as total displacement upon total time, v average. Okay, so this is important, just remember this, and you can do it for any whatever is asked to you. If I can ask you average displacement over time, average velocity over displacement, whatever, just remember average of x over y is integral x dy upon integral dy. It may simplify or it may not simplify, but you have to check it whenever it is done. One more important thing, if nothing is mentioned, then it is understood that it is average over time. Like suppose if I only tell find average velocity, and I have not tell you over what, over distance or over time, whatever it is. So if nothing is mentioned, you will take average over time. So again we have derived that average velocity is what we have just derived, that average velocity is given by total displacement upon total time. Similarly, your speed will be total distance upon total time. You can see that. So now there can be good sums formed on this part. So I'll give you one sum. Take 2 minutes and solve this sum, and then we can discuss this sum. So the question is, the train moves as follows. So there is a train and it moves as follows. So the train travels 1/3 of the time with velocity, the train moves 1/3 of the time with velocity 24 km per hour. So the train moves 1/3 of the time with velocity 24 km per hour. So this is the 1/3 time. If total time is t, this is your t by 3. Then the rest of the time, train moves with velocity 18 km per hour. You have asked find the average velocity of the train in the complete path. So I'll again repeat the question. The question goes, a train travels 1/3 of the total time, 1/3 of its total time with velocity 24 km per hour. The remaining time it travels with 18 km per hour. So you are asked find average velocity. Find average velocity or average speed. In this case it will be same, as it is in same direction. Okay, take 2 minutes, solve. And stop. Okay, so we'll check See, now here I can assume total time as t. So this will be the train is moving with velocity 24 km per hour for time t by 3, and for the rest of the time will be 2t by 3. It is moving with 18 km per hour. What is the average velocity for me? So average velocity is total displacement upon total time. I know total time is t, so I'll divide by t. Total time for me is t, so total time is t. For displacement, 1/3 part I can calculate what displacement is, and then 2/3 time I can also calculate what the displacement is, because I know displacement is equal to velocity into time, right? So since velocity is different in 1/3 time and the rest 2/3 time, I'll calculate them and I'll add them. So for 1/3 time, your displacement will be 24 into, let's say, t by 24 into t by 3, and plus it will be 18 into t by 3. So if I add them, this t will get cancelled out. So I'm left with 24 by 3, and so that will be 8 plus 6. So my answer will be 14 km per hour. So you have to again check for units. I know here it won't affect, so I am taking it directly. So my average velocity in this part, in this sum, will be 14 km per hour. Okay, let's take one more sum so you can get habitual to this types of sums. So let's start. This will be a good sum. So the sum says a car travels 1/3 distance. Okay, car travel 1/3 distance with velocity. A car travel 1/3 distance with the velocity 18 km per hour. Then in the remaining time, that is after traveling 1/3 distance, in the remaining time it travels 1/3 time. In the remaining time it travels 1/3 time with 12 kilometers per hour, and finally completes the journey with velocity 10 km per hour. 10 km per hour. So you have to find average speed. So I'll again repeat the question for you. A car travels 1/3 distance with velocity 18 km per hour. In the remaining time, the car travels 1/3 of the remaining time with velocity 12 km per hour, and lastly travels with 10 km per hour. Take your 2 minutes and solve. and stop. So in this they have combined your distance and time, so you have to draw your diagram clearly to look what it is. So firstly he's saying, let's assume total distance is d. So he's saying for 1/3 distance, so I'll write this as d by d. The 1/3 distance the car is traveling with 18 km per hour. Let's say this is my d by 3. Then he is saying for the remaining time, let's say from this point to the end point the car takes time t. Now this total distance was d, and let's say this time is t. So he is saying for the 1/3 time, so I'll write t by 3. So let's say from this point to this point the car travels 1/3 time, the car travels with 12 km per hour, and finally completes the journey with 10 km per hour. So in this you can simultaneously solve all the three. So I'll first part find average velocity in the time part, that is this second and third part. So in second and third part I know let's say v1 average. So v1 average will be total time is t, so I'll divide it by t, and my total displacement will be speed into time. So it will be 12 into t by 3 plus the remaining time will be 2t by 3. So it will be 2t by 3 into 10. Again t will cancel out. I will be left with 4 plus 10 by 3. So this will be 22 by 3. So my average velocity for this part is 22 by 3. So now my sum has been converted to the car travels 1/3 distance with 18 km per hour and remaining distance. So this will be d by 3, and then this will be 2d by 3. So remaining distance it travel with 22 by 3. So it is easy for us. So I'll write again a final average velocity final. Average velocity final will be, I have to take average for this part. Now in this part I know total distance, so total displacement. So total displacement is d. So I'll divide d and I have to find the total time. So total time will be this distance upon velocity, this distance upon velocity. If I add both of them I'll get total time. So my total time will be, my first path length is d by 3 divided by 18 and plus 2d by 3 divided by 22 by 3. Okay, so let's solve this. Here also your d will get cancelled out, so I'll be left with 1 divided by, this will be d by 3, so this will be 1 into 18 into 3 plus this will be 1 upon 11. So you can simplify this and you can get your answer. Okay, so I'll give you one more sum. Take this as a homework, try this, do comment your answers in the comment section, and I'll verify the answer and I'll tell it to you. Now this is a good sum. Okay, so take down a sum. So this is a sum which you have to solve for homework and you have to comment down the answer in the comment section. So take down the sum. The sum goes, a racing car travels with 90 km per hour in the first loop. So this is your racing loop. So the car is taking loops on the circular track. So he's saying a car travels with 90 km per hour in first loop. So the question is, with what velocity should it travel in second loop so that the average velocity of both loops will be 180 km per hour. Okay, take a note of this and try it at home. So I'll repeat the question. Car travels with velocity 90 km per hour in the first loop. With what velocity should it complete its second loop so that the average of both loops will be 180 km per hour? So do solve, comment, and reach out to me if you have any doubts. So in your uniform motion part, these are the only variations that they can ask you. They will ask you direct sums, or they can ask you sums in average forms, like find average velocity, average speed, and this types of the sums. So do remember how to take average, the formula for average, and then do remember how we have solved this. Okay, so this was your formula for average. Do remember this: average of x over y is integral x dy upon integral dy. So now let's move on to second type of motion. This is a very interesting part of the motion, and it is widely covered in your syllabus. That is, most of the sums will be from this part of the motion, that is uniform accelerated motion. Uniform accelerated motion. So in the kinematics part 1 video, which was the previous video, if you have not watched, go and watch that video first. We have derived two equations for this, right? What was the two equations that we have derived? So we have derived the two equations are v is equal to u plus at, and we have derived v square is equal to u square plus 2as. Now I can simultaneously solve these equations, and I can get you more let's say more three equations that you can remember to get your solvings fast. Usually you will see three equations. The third equations you get by simultaneously solving this, that is s is equal to ut plus half a t square. Now we have derived this in last two, and then we simultaneously solve this to get this equation. So this is your first equation, this is the second equation, this is your third equation. Now I'll again define the terms for you. U is our initial velocity, v is our final velocity, a is our acceleration, s is our displacement, t is our time. So first equation we'll use when the information of initial velocity and final velocity is given to us, or initial velocity and time. So any two of the three is given to us, that is initial velocity, final velocity and time, then we'll use this equation. Now in the second equation, if the information about displacement, initial or final velocity, any two of this is given to us, then we'll use this equation. In the third equation, if information about displacement, initial velocity or time is given to us, then they will use this equation. Now there is one more equation which I'd like to give you, that is s is equal to vt minus half a t square. Now again, this is also easy to remember. Here it is initial velocity, here it is final velocity. So if information of final velocity is given, you can directly use this. You don't have to simultaneously solve this and get your answer. So this will save your time. One more equation I'll give you is s is equal to v plus u by 2 into t. So these are the 5 equations you can remember to solve uniform accelerated motion. We'll take some sums over this, and after this I'll give you a shortcut that you can do the sums without using these formulas. You can do it faster than using these formulas. So just wait for this. We'll take 2 or 3 sums by using these equations, so you get familiar with these equations, and then later we will see how much time we can save by using the trick. Now for using these equations, you have to follow the sign convention. So you can take whatever sign convention you follows. So I'll give you the basic sign convention. The positive upwards is positive. If any value is downwards, it will be negative. Any value rightwards is positive, and any value leftwards will be negative. So let's take 2 or 3 sums and then we can solve this. So let's take a very simple sum. So the simple sum given to you is a ball. There is a ball. It is thrown upwards with velocity 20 meters per second. So now what will happen to ball? It will go up. It will go more up. Will it keep going up or will it stop? It will stop, right? At a certain moment its velocity will become 0 and then it will again fall down. So we have asked, a ball is thrown upwards with velocity 20 meters per second. Find the total time it takes to go up and come down. So you have asked find total time, and you have asked find h max, maximum height reached by the ball. So let's solve this. So if a ball is thrown upwards with velocity 20 meters per second, so I'll consider this point and I'll consider this point because one information is known to me, that velocity at this point is 0. How do I know? If velocity is not 0, it will keep going up. Since it is not going up, that means velocity has become 0 over here and then it is started to fall. So now between these 2 points I can apply my equation and I'll get my answer. So now I know initial velocity, this will be my initial velocity and this will be my final velocity, and I need to get time. So I'll use my first equation, that is v is equal to u plus at. So my v is 0, that will be equal to 20. Since 20 is upwards, I'll take 20 as positive, plus our gravity always act downward. In this case we'll take gravity 10 meters per second square. For simplification purpose, it will be 9.8 or 10. In this sum we are taking it 10, and gravity acts always downwards, so I'll write minus 10 and into t. So if I simplify this, I get t is equal to 2 seconds. So my time from here to here will be 2 seconds, and then here to here will be 2 seconds. So total time will be 4 seconds. Now to find height, I'll use my second equation. Second equation is s is equal to ut plus half at square. S is equal to ut plus half a t square. So for height, I'll take these 2 points because this is the height that I have to find. So again my s will be my height, that will be equal to u into t. So u will be my 20 into time. Time is 2 seconds. From here to here time is 2 seconds. 20 into 2 plus half into minus 10. Gravity is downward, so it will be minus 10 into time square. Time square will be 2 square. So this will be 40 minus, this will be 5 4s are 20. So my answer will be 20 meters. You can also use this equation as final velocity is known to me. So you can use s is equal to vt minus half a t square. Let's see what we get our answer. Final velocity is 0. So this will be 0 into 2 and this will be minus half. Acceleration will be minus 10 into t square, that will be 2 square. So this will be 0 plus 20. So again this will give you 20 meters. So we have got our same answers. Okay, so if you have any doubt on this sum, you can reach out to us and we'll help you. Let's do one more sum. Now this is your vertical motion. This also falls under motion under gravity. You can call whatever it is. I usually take all the sums in one single part. So let's solve one more sum. So now the sum is, so this is a good sum. So the sum goes, a train is moving. So the sum is, a train is moving with uniform acceleration. Train is moving with uniform acceleration. Front of the train, the front part of the train crosses a pole with speed u. So front end of the train passes the pole with speed u. Backmost end of the train crosses the pole with speed v. Okay, so you have asked with what speed midpoint of the train cross the pole. Okay, so the question is, I'll repeat it in a diagrammatic form. So let's say this is your train. Let's say this is point A, this is point B, let's say this is point C. So this is your pole. So point A So the train is moving with uniform acceleration, so train is accelerating uniformly. So front end, the information given to you is the front end crosses the pole with velocity u, the back end, last end, crosses the pole with velocity v. You are asked find with what velocity did the midpoint of the train cross the pole. So take your 2 minutes and solve. And stop. So this is a good sum. You can take more time if you want, just pause the video and you can take your time. So I'll solve the sum. So again I'll repeat the question. So this is my train, this is point A, the end point I have written as point B, and the middle point is point C. So this is my pole. So point A crosses with velocity u, point B, the end part of the train, crosses with velocity v. So you have asked with what velocity point C crosses the pole. So let's assume total length of the train as L. So we have assumed total length of the train as L. So I know this part crossed with u and the last part crosses with v. So I'll use the last formula. I've given you the 5 formulas. So I'll use the last one. S is equal to v plus u by 2 into v plus u by 2 into t. So in this part my S length, my S distance will be L, because this total length is L, and I know initial and final velocity. So this pole passes with u and the last part passes with velocity v. So it will be u plus v by 2 into t. So from here I get time is equal to 2L upon u plus v. So I got time as 2L upon u plus v. I'll find my acceleration. How can I find my acceleration? I'll use the first equation. V is equal to u plus at. So I know final velocity is v, initial velocity is u, plus I'll substitute the value of time, that is 2L upon u plus v. So if you simplify this, you get your acceleration as, it will be v minus u. So if I take this u, it will be v minus u, and then it will be multiplied by u plus v divided by 2L. So this is your this is your answer for the acceleration. Now finally you have to find with what velocity did the point C cross the pole. So let's solve this. So for this I'll use my third equation, that is v square is equal to u square plus 2as. Okay, so let's see v as the velocity of point C. So I'll write velocity of point C square. is equal to u is again my initial velocity, so u square plus 2 times acceleration will be my v minus u into u plus v divided by 2l, and s will be my displacement, so displacement this will be l by 2 as it is midpoint, so this will be l by 2. L and L got cancelled, so again this 2 and this 2 is cancelled, so I am left with my answer will be v velocity of point C will be root of velocity of point C will be root of, so velocity of point C will be, I'll be left with b u square. Now this is a plus b, a minus b identity, so I can write this as plus v square minus u square, and since there is 2, so I'll separate this by 2 by 2, so I am left with my final answer will be, this total will be again root under root, so my total answer will be under root v square by 2 plus u square by 2. So this will be my final answer. So let's solve one more good sum, then I'll show you the trick and I'll show you we can use the trick to solve the sums quickly. So let's move on to the last sum of this type without using tricks, with using equations. So the question is, a bullet loses 1/10 of its velocity when it passes to a bunker. So this is a bunker and this is a bullet. So the question is, the bullet loses 1/10 of its velocity when it passes through one bunker. So it is asked, find the number of bunkers to reduce the velocity to 0, that is to stop the bullet. So the question is, if this bullet is moving with velocity v0, after it come out of the bunker, its velocity is dropped by 1/10, so its velocity is 9/10 v0. So you have to find me the number of bunkers to be placed parallelly to stop the bullet. Take your 2 minutes and solve. And stop. So let's solve. In this question I'll be using the third formula, that is v square is equal to u square plus 2as. So let's solve. So I'll apply this for this condition, that is for one bunker. So one bunker, my final velocity is 9/10 v0 square is equal to initial velocity square, that is v0 square, and since the velocity is reducing, so it will be retardation, so my acceleration will be minus a. So I'll directly write minus 2a and length for one bunker is L. So if I simplify this, I get V0 square. I'll take this at this side and this at that side. So I'll get 1 minus 81 by 100 is equal to 2a into L. So let's call this my first equation. Now second equation, I'll again use this formula for my V0 to 0. So my final velocity in the second part, so I'll assume that I have put n number of bunkers and the velocity is V0 and final velocity of the bullet is 0. That means it gets stuck at this last bunker. So let's put this values in this equation. Final velocity is 0, initial velocity is V0 square, again minus 2a, and length will be number of bunkers into length of one bunker. So that will be n upon L. So this will be V0 square is equal to 2a n into L. So this is my equation 2. So if I divide equation 1 by equation 2, you can get the value of n. 2a and L will cancel out, and V0 square will also get cancel out. So I'll divide 2 by 1. So I'll get the value of n. So I'll get value of n to be, it will be around 5 point something. So it is 5 point something. So I'll approximate it to 6 because it will get stuck in the 6th bunker. So number of bunkers required to stop the bullet is 6. Now let's move on to the trick part. This is a very good trick. You will enjoy this. And if you implement this trick properly, you don't have to remember the formula and you can save a lot of time. So this trick can be only applied for constant accelerated motions. So like your acceleration should be constant. To apply this trick in the sum, the acceleration should be constant, and there is one condition. So the condition is either u should be 0 or v should be 0. That is, either initial velocity should be 0 or final velocity should be 0. Either one of them should be 0. If it is not there, then you have to introduce an intermediate point where you can make it 0, and then you have to solve it in two parts. When we'll do the examples, I'll show it to you how it is done. Okay, so we'll again recap the variables in kinematics. So it is initial velocity, final velocity, time, height or displacement. If it is vertical, we call it height, and horizontal, we call it displacement. So if once this condition is satisfied, you just have to remember 3 boxes. So I'll tell you what these 3 boxes are. So we have 4 variables. Out of 4, one variable will be 0. That is, either u or either v should be 0 to apply this trick. So let's say u is given to you, that is, one of the velocity is given to you and other velocity is 0. So if in any sum, let's say our the previous sums of the ball which we have done, a ball is thrown with some velocity. At the topmost point, its velocity is 0. So it is perfectly applicable here. So if the velocity is known to us, then the time will be given by u by g. Time is u by g, and the height will be given by u square by 2g. The time is u by g and height will be u square by 2g. If height is given, let's say between 2 points, the height is given to you. If height is given to you, your time will be root 2h by g, and your velocity will be root 2 gh. Okay. Lastly, if time is given to you, then your height will be half g t square, your time will be half g t square, and your velocity will be gt. Okay, so you have to check whether acceleration is constant, then you have to check whether initial velocity or final velocity, one of them has to be 0. Then see which value is given. If u is given, move to this box and get the other 2 values. If height is given, move to this box, find the other 2 values. If time is given, move to this box and find the other 2 values. Take few moments and just go through this. Remember all the 3 boxes, and I'll show you how fast we can solve the sums. Okay, so let's take example so that you can understand it very clearly. Let's take our the for previous example of the ball. So in the last sum I told you a ball was thrown with velocity 20 meters per second, so it goes up and come down. See, now if I consider this point, here velocity is 20 meter per second, and if I consider this final point, here also velocity will be 20 meters per second downwards. So I cannot apply metric. So you have to look for where your time is 0. So where your velocity is 0. I know that topmost point where velocity will be 0. So I will choose these 2 points. Now my condition is satisfied. This constant accelerated motion and one of the velocity is 0. So now between these 2 points, what value is known? Velocity is known. So if velocity is known, I'll move to first box. If velocity is known, time is u by g. Height will be u square by 2g. So see how fast you are able to get the answers. No confusion of sign convention, no solving mistakes, nothing. Just you will get your answers very fastly. So if velocity is 20 meters per second, the time will be u by g, that is 20 by 10. So this is 2 seconds. So this is how fast you can able to do it. Height will be u square by 2g. So it will be 20 into 20 upon 2 into 10. So this will be 20 meters. So this is how fast you can do it. We'll take few more sums so that you can understand more. So now let's take few more sums so you can understand it more clearly and see how fast we can solve this using this. Suppose if I see a ball is thrown with some velocity, the maximum height reached by the ball is 100 meters. So you have to find total time and the velocity with which the ball was thrown. Now here we again will choose these 2 points because I know velocity is 0 over here. My condition will be satisfied, and if height is given, we'll go to box, the height wala box. So if I go to height box, then if height is 100 meters, time is root 2 h by g. So it will be root 2 into 100 by 10. So my time will be root 20. So this time will be root 20 and this time will be root 20. Total time will be 2 times root 20. This is how fast you can solve this. So now for velocity, your u will be root 2 gh. So it will be root 2 into 10 into 100. So it will be root 2000. Again, if time is given to you, if I say total time required for the ball to go up and down is 8 seconds. So this total time is 8 seconds. I know this time will be 4 seconds. From here to here, the time will be 4 seconds. So if time is given, my height is half g t square. It will be half 10 into 4 square is 16. So again this will be 80 meters. And for velocity is gt. So it will be g will be 10 and time will be 4. So velocity will be 40 meters. See, now let's take a good sum and see if we can solve this. So let's take that sum. The sum is a man is standing on the top of the tower. The height of the tower is 100 meters. So a man is standing on the top of the tower. The man throws a ball upwards with velocity 20 meters per second. The ball will go up and come down. So you have asked find total time and velocity with which the ball strikes the ground. That is Vs, velocity with which the ball strikes the ground, striking velocity. Okay, take 2 minutes and try. off. Now in this we'll choose this point because velocity is known, that is 20 meters per second, and I'll choose this point because here velocity is 0. So I'll divide this in, this is my part 1 and this will be my part 2. So in part 1 velocity is given. So if velocity is given, then time is what? U by G. So it will be 20 by 10, so that is 2 seconds. So from here to here my time will be 2 seconds. And height will be u square by 2g, that will be 20 into 20 upon 2 into 10, so that will be 20 meters. So this height I get it as 20 meters. Now moving on to part 2. In part 2, what value is known to me? This velocity I have to find, and total time I have to find. So I can know height. So this total height will be this 100 plus 20. So total height will be 120. So if height is given, I'll move to height box. So in height box, if height is given, time is root 2 h by g. So my time will be root 2 into 120 divided by 10. So this will be root 24. So time for this is root 24. So I've done, my total time will be time in first part plus time in second part, that is 2 seconds plus root 24 seconds. This is my total time. Again I have to find striking velocity. So if total height is known, my velocity is root 2 gh. Velocity will be root 2 gh. So it will be root of 2 into 10 into 120. So my velocity will be 2400. See, this is how the fast you can solve the sums. So that's it for this video. In next videos we'll take up few more good sums, exciting sums, tricky sums for this tricks, and which you will solve very fast and you will get an upper hand your competition. So stay tuned for the next part of this kinematics session, and you will surely love the next part, because in next part I'll show you many of the sums that you can solve fast using these tricks. For now, go and practice all the sums in uniform motion and uniform accelerated motion. See how you are able to apply the tricks. If you have any doubts, do comment in the comment section or reach out to us. We'll be happy to help you. Thank you.